Hello, everybody, and welcome to today's episode of Sadlier School Live. My name is Camberly Woods, and I'm thrilled to bring back Dr. Matthew Beyranevand. Hello, Matthew.
Hello, Cam. How are you doing today?
I am doing great. Thank you for being here with us today, and I am really curious about today's topic because you kept it super secret from me. All I know is it's called Pascal's Triangle.
You're exactly right. And I'll tell you, Cam, at this point, I've known you for a couple years, so I feel like we're kind of friends now. So I feel like I can put you on the spot here today in regards to engaging you with a mathematical activity that you know nothing about, spur of the moment, to get a true, authentic experience for one of my favorite types of questions, both as a teacher, doing with students from ages 8 up to maybe 15, as well as a parent. And I want to share that with our viewers today and give them the opportunity to experience an activity that has a low barrier of entry, but yet you can do some amazing things, a very high ceiling with it. And it's called Pascal's Triangle. And so if it's okay with you, so we'll be able to get started. What is it you want to say? I'm sorry.
Yeah, I just wanted to let everybody know too that the activity you're walking us through today, you provided me with a link on that, and I'm going to be dropping it into the chat on this video as we're walking through it.
Okay, excellent. So I have just shared my screen, and Cam and others should be able to see here. What I have is this crazy figure with some numbers in it that I just referred to as Pascal's Triangle. And Cam and others watching on Facebook Live, take a moment, and all I want to ask of you is what things you notice in regards to this pattern here, and what things might you be able to fill in spaces as to what you might hypothesize the numbers would be.
Yeah.
So Cam, yeah, go ahead. Share with me any of your initial thoughts when just looking at this, if you could.
Yeah. So first, it's that we have ones going down on the outside or the perimeter of the triangle. Another thing I started to quickly notice was as we get down to like the third row, it starts with 2 and then 3. But then when we get to the next row, that pattern kind of breaks. However, when I look at the triangle and I go down to like your second row of ones, on a diagonal, I see it's going 1, 2, 3, 4, 5 as well.
So let me pause for a second, and you picked up some great observations. And as I said, it's a very low barrier of entry because I'm not giving you any specific directions as to what you have to figure out and solve. Math, if you listen to anything that I've said over the course of these videos that we've done together or the master classes, math is beautiful. We should just play and we should be able to authentically experience it. So yes, the things that you just said were great. The pattern is we have the number 1 going down, and it likely would continue in both directions. And then you very astutely pointed out that, look, it goes 1, or if we look here, 1, 2, 3, 4, 5, and then what number do you think would go here, Cam? 6. So we would go 6, 7,
8, 9, and just fill that in all the way down.
Exactly. And those we refer to as our counting numbers, 1 and going up. And then you see it's the exact same thing on this side as well.
Yeah.
Okay, 4, 5, 6, etc. Now, here's what I want to ask you. What do you predict the number would be here? And I don't know if you could see the pencil mark that I'm using. What do you predict that number would be based on any observations you can make of this here?
Yeah, so I'm going to go with 10 to just kind of mirror what's happening on the other side.
Okay, so there's a nice observation that you made that there is a line of symmetry in the middle and it's a mirror image of each other. Let me ask you another question, Cam. Looking at the numbers above it, is there any other way that you can see how you would get the number below?
Yeah, so I was looking here at the 1, 3, 6, 10 column, let's say.
Okay.
And I kind of noticed that we're jumping up by 2 and then 3 and then 4. So maybe if we jumped up by like 5 on the next row.
Oh, I like what you're saying here. The difference is 2, then 3, then 4. So you would say this would be 15 here?
Yeah.
And then if you look on this other side, this might be 15 also.
As well. Yes.
Okay. Now, what information or what can we use based on what we've already identified to try to figure out what number would be in the center here?
This one's the one that's gonna stump me, Matthew.
This one is a little bit tricky, and I will tell you there's also a pattern. If you look at the previous numbers above it, it can help figure out the number below it.
Okay, so I'm guessing it's going to be, we're increasing by 2 on that row. But could I also go down on the side and do like the same thing with the 1, 4, 10 and
Absolutely. There's always more than one way to solve a problem, Cam. You know that as well as I do from the work that we've been doing together. So what are you hypothesizing it might be?
Okay, so there we're increasing by 3 and then we increase by 6. So we're almost like doubling on our increasing. So I'm guessing we're gonna add 12 to 10 since we did 3, 6, 12. So 10 plus 12 is gonna be 22.
Okay, that's a very good answer. I like your thinking behind it. It's not correct, but you know what? That's okay. What's great about your answer is that you had rational thinking and you could support your answer. Mathematics is not about correct answers. Math is about the study of patterns, and this is one of the most beautiful patterns in all of mathematics here. And what you said, although not correct, I absolutely loved. The answer is actually going to be 20. And another way to look at the pattern is that to find the value, you can look at the sum of the two values above it. So here, 3 plus 3 is 6. 6 and 4 make 10. 10 and 5 make 15, et cetera, et cetera, et cetera.
It's funny how like a few seconds before you revealed the answer, my eyes saw it and now I can't unsee it.
Yes, yes. Now, we can actually explore so many things that have to do with this particular triangle. And what I want to do in the time that we have left for today is just share for the viewers a few observations that I would not necessarily just right away show with my child or my students, but have them gather it through the similar style to what I was doing by asking questions. Let me just show you a few interesting things here. Okay. The first is that, as you correctly said, these are our counting numbers: 1, 2, 3, 4, 5, 6, 7, etc. In this column, or this column, these are what's called the triangular numbers. Why are they triangular numbers? Well, we have 1 dot, and then if you do 3 dots, you make a triangle. And then if there's 6 dots, we add 3 more, it makes a bigger triangle. And then if we add 4 more dots, now there's 10, it's a bigger triangle, etc., etc. Another thing which is very cool is that if you make a little hockey stick, if you will, and let's say you go 1, 2, 3, what does it add up to? Go to the right, 6. 1, 3, 6 plus 10, what does it equal? 20.
Oh, wow.
Etc. And then one other thing to look at, if you look at the sum of each of the rows, on the first one, it's 1, then it's 2, 4,
6,
4, 8, 16. It keeps doubling the sum of the digits. And if you think about it in exponential terms for middle school students, it's 2 to the power of 0, 2 to the first, 2 to the second, 2 to the third. And so the row number is the exponent with a base of 2. And then if we go deeper and deeper, and you can see that on the link that I just shared, we can go into something that's called the Fibonacci sequence, which is an absolutely beautiful mathematical sequence. And we can go on and on and on. And you can really begin to examine some high-level mathematics here. And there's no actual questions that I'm posing. There's no trying to solve this here. It's the idea of what I said before about what do you notice? What can you just figure out on your own? And then having a teacher or a parent kind of guide and ask questions of you in a very open-ended manner to develop the pattern, to understand the pattern, and to see some operations embedded within the pattern. And you can literally spend an hour on this, and it can be done in a joyful, fun manner. And I will tell you, both with my own children as well as students that I have worked with in the upper elementary and the middle school, this is a joyful, authentic learning experience that deepens your conceptual understanding of numbers, and not something that students will say, when would I ever have to use this? Because you know what? You're never going to have to use this in the quote real world, but your problem solving, your thinking, your critical thinking is at the peak when you're doing something like this.
I love it. And this is an activity I'm going to take today and walk through with my kids. I know that they're in the lower elementary ages, but even looking just at the top of the triangle, they can do some of those same types of things, recognizing the patterns and, you know, seeing that the ones are on the outside. So this is easily adaptable for even adults and children.
Yep. So there's a link that I shared there that shows you on a very elementary level all the way up to high school mathematics that you can do with it. And then you just have to print it out, print out a copy of that here, share that with the kids, and just explore and have fun. And I will tell you, it will lead to a very positive experience in doing it, different than solve these 10 problems over and over again. Thumbs down on that particular approach.
Well, thank you so much. And we should ask everybody watching today, were there patterns in the triangle that you noticed that we didn't? Maybe they're going to stump Dr. B.
I love it. I would love to hear any questions, thoughts, comments, or other observations that were made, because there's quite a few that we didn't even get to in the short amount of time. So I would love to see what you have to say in the comments.
Okay, well, I want to thank everybody for being here with us today. We will be back. Well, not Dr. B. He's going to be back next week with me on Tuesday and Wednesday. So come back, because whatever he teaches us on here is always super enlightening. So he'll be back next Tuesday and Wednesday. I'll be back tomorrow at 3:00 p.m. Eastern time, 12 o'clock Pacific. So I hope to see you there.
All right. Thank you so much, Cam. Thank you, everybody, for watching.
Talk to you later.
Bye-bye.
Bye.